So what I want to talk about this afternoon are inequalities with polynomials and rational functions. And let's start out with polynomials. The idea is this. Let's say we have polynomial. It's doing this, and then eventually it goes off to infinity. And it intersects the x-axis at these points. A, B, C, and D. So we want to ask the question, where is f of x greater than 0? Now again, f of x refers to the y value. So if this is our x-axis here, well, what we're asking is, where along the x-axis is this polynomial above it? Well, it looks like from a to negative infinity, the polynomial is above the x-axis. It's also above the x-axis between b and c. So we'll union that to b and c. And then finally, it's above the x-axis to the right of d. And notice that I'm using the parentheses. It means we're going to exclude the values a, b, c, and d, because this is where the polynomial equals 0, where it crosses the x-axis. Now, we could also look at where this is less than 0. So this is where we're below the x-axis. So we're below the x-axis from a to b. And we're also below the x-axis from c to d. So that's the idea of having f of x greater than 0 or f of x less than 0. So there's basically a procedure for figuring this out. And oftentimes we don't have the picture graphed for us. So we have to do this without using graph. And the way we can do that is use what are called test points. Now a test point, let's say it's a point between our intercepts, and it's also a point on the far sides. And what these points will tell us is whether the interval the test point's in, whether that interval is above or below the x-axis, or f of x is above or below the x-axis with that interval. So, for example, let's say we evaluate this test point. We're going to get something here. Now, because there are no x-intercepts in this interval, that means if this is negative, all the points of f of x will also be negative. They can only be positive if they cross over the x-axis. And since this doesn't happen, then if this is negative, all of its friends here are going to be negative. We won't see a change in sign for f of x until we pass through the intercept and onto the other side. So that means once we pass through here, say, and we do a test point and it comes out positive, well then this point and all the other points with it on this interval, they're also going to be positive. And we know they'll always be positive because you can only become negative if you pass through an x-intercept at the ends of the interval. So the points on the inside are all going to have the same sign. So we're going to use test points. So there's a general procedure we can use. So what we'll do first, we'll set f of x equal to 0. And then we'll solve for x. And this will give us the x-intercepts. Then we'll choose test points. I'll call them TPs. We'll look between the x-intercepts and then on the far sides. Of the x-intercepts. And then we'll test these TPs, and then we'll just determine and this depends on the question we're being asked, but we might be asked to determine where f of x is greater than 0, or where f of x is less than 0. So let's take a look at some examples. So let's say we have this. We want to find where on the x-axis is 5x squared, x squared minus 5x plus 4 is greater than 0. First thing we're going to do, set it equal to 0. Now this is something you can factor, and you can use the guess and check method. And what you'll get is x minus 1, x minus 4 is 0, or this is 0 when x is 1, this is 0 when x is 4. I'm using the zero product principle, and the idea of the zero product principle is this. Something times something is 0 only when one of those is 0. 3 times 0 is 0, or 0 times 4 is 0. But the product of two non-zero numbers, that's never 0. So if there's a product of two things and you get 0, one of them at least has to be 0. So this will become 0 when x is 1. This will become 0 when x is 4. So we now know the x-intercepts, 1 and 4. So we know this is where the polynomial crosses the x-axis. What we want to find out is it positive? Is it going to be positive or negative? Is it positive or negative? Is it positive or negative? To do that, we're going to use test points. So let's choose, say, 2. Over here, we can choose 10, just because it's easy to do multiplication with 10. And over here, I'm going to choose 0, because, well, multiplication's easy with 0. So let's find out what f of 0 is. So f of 0, 0 squared minus 5 times 0 plus 4, well, that's going to be 4. And that's a positive number. So that means everything here is going to be positive. Now there's a 0 here. There's a 0 up here. So this is going to be positive. And then we should see this turn out to be negative. We'll just verify that, but with polynomials, because they're continuous. Now it is possible, though. It is possible, and depending on the multiplicity of a factor, it doesn't necessarily have to cross over the x-axis at these points. An x-intercept is a contact point. If the multiplicity of a factor, this is your factor, if its multiplicity is odd, 1, 3, or 5, it will pass through. But if the multiplicity is even, that means the factor has an exponent of 2 or 4 or 6, then it could just hit this and then bounce back up. We could have more positives here. That is something that can happen. Now, it's not going to happen in this case. This has a multiplicity of 1. Remember, when there's no exponent there, there's really an invisible 1 for the exponent. Just like there's an invisible 1 for a coefficient if you have x with no coefficient attached to it. There really is that invisible 1. So this has an invisible 1. So does this. So they have multiplicities of 1. That means they have an odd multiplicity. So we're going to see them cut through here. So we should see negative here. And then as it cuts through here, we'll get positive again. Well, we'll verify that. 2 squared minus 5 times 2 plus 4. So this will be 4 minus 10 plus 4 will be negative 2. And so that's negative. So for this interval, it's negative. Finally, and we'll see this turn out, f of 10, 10 squared minus 5 times 10 plus 4. This will be 100 minus 50 plus 4, and that's 54, and that's positive. So where is this greater than 0? Well, it's going to be on this interval to the left of 1, and this interval to the right of 4. And since we don't have an equal to here, we don't include the intercepts, because we don't want the function to be equal to 0 in this case. In this case, we don't. So the answer is this. And there we go. Now let's take a look at another one. So once again, we're going to start out by setting it equal to 0. Now, for this, we're going to use the guess and check method. And I do want to mention something about the factoring for the last problem. So we had this. I use what's called the guess and check method. And the idea is that when you have a 1 as the coefficient of your lead term here, and we're talking about quadratic, then we can do this. We guess 2 numbers that add up to the number attached to the variable doesn't have a square. Or if you put this in standard form, 2nd degree, 1st degree, 0 degree, then the middle term. You want 2 numbers that add up to the middle term and that multiply to the last term. And what we had was -1, -4. Multiply these two, negative and negative is positive. Add them, you get -5. And so this broke down like this. Or finally, Because you add a negative, it's the same as subtraction. Adding a negative is the same as subtraction. All right. And so that's how I did that factoring. So this section's a good review of factoring. Now this one, we do a little bit of guess and check with it, but it's called the AC method. And the AC method, well, we're going to multiply A and C to start. What I mean by that, A is the lead coefficient. So if you put this in standard form, degree 2, degree 1, constants are degree 0. The coefficient of the degree 2 is a 3. This is 10, constants minus 8. So the AC method starts out like this. We multiply A times C, and we get negative 24. And then now we do the guess and check. We need A plus B, again, to add up to that middle term, coefficient, but they need to multiply not to the constant term, but to A times C, that number, negative 24. So two numbers that add up to 10 but multiply the negative 24, 12 and negative 2. There we go. Now next with the AC method is we rewrite the middle term. We say 3x squared plus, rewrite it as a sum of capital A plus capital B. Because 12 plus negative 2 is 10. Now again, the whole point is we're trying to see where this is equal to 0, so we're going to try to figure it out by factoring. Now, if you want, and you just don't want to bother factoring all these quadratics with AC methods and guess and check methods, you could just use the quadratic formula. That'll get it done too. And some of these aren't going to factor in, at least not using these techniques. And so using the quadratic formula, that might be the only option. So we distribute x. So we're going to try to factor this by grouping now. This is all part of the AC method. And I'm going to group these two and then group these two and look for something that I can factor out or extract from both of these. Then also look for something probably different that I could extract from both of these. And whether or not I group these correctly, we'll find out. And I'll show you how we know that pairing these two and pairing these two was the right thing to do, instead of, say, pairing these two and pairing these two. So let's pair these. Well, here I can say extract a negative 2. I better write this in terms of negative 2. Kind of looking ahead here. Negative 2 times 4 equals 0. So just to illustrate or explain, negative 2 times 4 is negative 8. Adding negative 8 is the same as subtracting 8. Same thing. So pair these up. Pair these up. I'm going to go for 3x and 3x. So I can pull out a 3x here. I'm going to pull out a negative 2 here. So there's 3x, x plus 4, plus negative 2, pull out negative 2, and we get left with x plus 4. Nice, that worked out. So why is this a good thing? Well, this tells us the grouping that we did in the beginning is actually going to work. When we extract something and then something else, we extract something from the two groups. If we're left with the same binomial, If the groups now have the same binomial, that means this has worked. So we can factor out that binomial. And there we go. We're still just trying to set this equal to 0 and find out what x values makes it 0. And probably if you're using the quadratic formula, you might have the answer by now. So yeah, if that's the better way to go for it. But I want to keep going through this way. This is something that, sometimes you're asked to do this. So a little practice on it doesn't hurt. All right, so again, zero product principle. So x plus 4, what makes that 0? Well, when x is negative 4. And 3x minus 2, when is that 0? Well, add 2 to both sides, divide by 3, when x is 2/3. So when x is negative 4, this whole thing becomes 0. When x is 2/3, this whole thing becomes 0. And remember, this is just a factored version of that. So that means this is 0 when x is negative 4, x is 2/3. So now that we know that, we have our x-intercepts. So we need some test points. Whew, we finally know where this polynomial crosses the x-axis. So test points we could use. Again, I'm looking for easy numbers for computations. There's 0 between negative 4 and 2/3. There's 1. And let's go negative 10. All right. So here's the point between the x-intercepts, and here's the points on the far side. So I gave these a blue color last time. I'm just going to use green for now, but still, far sides in between the x-intercepts. So let's find out the value of f, this right here, at these test points. So f of negative 10 is 3 times negative 10 squared plus 10 times negative 10 minus 8. So we'll get, well, you square negative, it goes away, it becomes positive. So this will be 100 times 3, 300, positive times negative, negative 100 minus 8. So this will be 200, 200 minus 8, 192, and that's positive. So keeping track of positives and negatives, here's zeros, and here we have positive. Now let's test 0. F of 0 is 3 times 0 squared plus 10 times 0 minus 8, and that's just going to be 0, 0. Subtract 8, you get minus 8. So this is all negative. And then finally, f of 1. Well, we get 3 times 1 squared plus 10 times 1 minus 8, over 3 plus 10 minus 8, and that comes out to positive 5. So it's positive here. So what's our answer going to be? Well, we want the intervals where this is less than or equal to 0. We do have an inclusion here. So that means we will include the x-intercepts. So we're equal to 0 and less than 0 between -4 and 2/3. And that's going to be our answer. All right. Well, let's take a look at one more. And this one has more of that factoring by grouping. I'll grab another pen here. So we want to find where this is greater than or equal to 0. And for this one, we don't have a quadratic, so we can't use the quadratic formula. We are going to have to factor by grouping. So I'm just going to go with what they give us and see what happens. So again, I want to set this equal to 0. And I'm going to group these two and these two. And from here I can extract a -4. From here I can extract an x squared. Oh, sorry, this is an x cubed here. Ooh. So we have an x cubed, a 2x squared. I can extract out an x squared. So let's see what we get. Hopefully this works. So if I extract x squared from this first group, get x plus 2. If we extract -4 from this group, we'll get x plus 2. Excuse me. So how do we know the grouping worked? We did that, we grouped them correctly or effectively. Well, we got the same binomial in each group, so we can factor that out. And there's more to this one. If you notice, this is a difference of squares. 2 squared gives you 4. X squared gives you, well, x squared. So the difference of squares, we can rewrite that. Oh. If you have a squared minus b squared, you can rewrite it a plus b, a minus b. So here a will be x and b will be 2. Now there's something interesting with this one, because we have 2 of the same factor. We could rewrite this like so. So x minus 2, it has an exponent of 1, that invisible 1. So it has an odd multiplicity. So what that says is, well, this is equal to 0 when x is 2. So at x is 2, our polynomial will pass through the x-axis. But this factor, or really 2 factors that are the same, they're going to be 0 when x is -2, because -2 plus 2 is 0, -2 plus 2 is 0. They have a multiplicity of 2. That means the polynomial it'll contact the x-axis at x is -2, but it won't pass through. It'll just contact it and bounce off. So this will provide one of those situations where you'll be checking your sign, you'll hit an intercept, and then on the other side of that intercept, the sign will repeat itself. You won't see a change in sign. Well, let's go through. Let's take a look. So this will be 0 when x is -2. This will be 0 when x is 2. So we have an intercept at -2, and remember this one has a multiplicity of 2. This one's going to have a multiplicity of 1. Now again, we want to look for test points. So something between -2 and 2, again, I say go with something that's not hard to computate with. Go with 0. And then here, I'll use the blue pen for the far test points this time. Last time I used that green pen. I'll use 10 and -10. So let's find f of -10. So we'll get -100, -1,000 actually. This will be 200 times 100 times 2, 200. Negative times negative is positive, that's +40. And then -8. So what that'll give us, -1,000 plus 200, that's -800. -800 plus 40 is -760. -760 subtract 8 is -768. So that means this interval, f of x is going to be negative. Oh, this will be blue. Now remember, this has a multiplicity of 2. So that means the polynomial will just contact the x-axis and then dive back down again. So that means if this is negative, this is also going to turn out to be negative. But again, let's say we weren't thinking about that. Let's say we just overlooked multiplicity. Well, again, we can just test that, see what we get. And this is 0, 0, 0, subtract 8, it's -8. Sure enough, it comes out negative. So that means we've got a negative. And based on the rules of multiplicity and the multiplicity of 2 here for that intercept, well, that's what we would expect. All right. So finally, f of 10. All right. So 1,000 plus 200 minus 40 minus 8. So 1,000 plus 200, that's 1,200 minus 40, 1,200 minus 40. 1160. Yes, 1160 minus 8 again is 1152. Double check that arithmetic. Yeah, okay. So that means we get positive. Now that's also predicted. And the reason we could predict that, this had a multiplicity of 1. It's an odd multiplicity. So that means the polynomial passes through the x-axis at this intercept. So if it's negative on this side, the polynomial will pass through and become positive on that side. So now we need to answer our question. Where is this thing positive or equal to 0? And we will allow for equality to 0, so that means we will include any x-intercept that's going to work with this. So where do we find this greater than 0? Well, it's from 2 and above. And where is it equal to 0? Well, we have to be a little careful here. It is equal to 0 at -2. We don't want to forget that. And then we union that with this interval. This is 2 to positive infinity. Now this might seem like an unusual answer, and it is. It's not one we typically get in this class. But we just want to know, where is this greater than or equal to 0? Well, it's greater than or to 0 here. It's greater than 0 on this interval to the right of 2. It's also equal to 0 at 2, so that's why we have the inclusion of 2. It's also equal to 0 here. So this point, we need to union with this interval. Now, intervals are just sets, really. So this is just sort of a set with infinitely many numbers, infinitely dense numbers. And so this is just one more number we need to union to that set. And that's it. So that's inequalities of polynomials. If any questions, let me know.